right, so we were talking about work energy theorem, right? And we were talking about certain conditions. And I told you that if the term completes one circle is there in your in the problem that you are doing, then the mathematical meaning of completes one circle for us would be that the velocity at the topmost point is root r(g), or the velocity at the bottommost point is root 5r(g). Right? This we have discussed. Okay? And I told you that if v is less than or equal to root 2gr, then the motion of the object, uh, motion of the object suspended to the string is within the lower semicircle. You cannot go beyond that. V is, if V is greater than or equal to root 5gr, then it will complete vertical circles. And the real pain is when V is greater than root 2gr and less than root 5gr. In this case, it completes an incomplete circle, goes into an incomplete circle, and thereafter it goes into projectile motion. Right? So today we are going to see lots of problems for this day. याद है ना ये सब सबको? भूल तो नहीं गया कोई? हेलो, सब लोग सो रहे हैं ना? मैं भी सोने जा रहा हूँ. So before we get into this, I want to first show you the use of these two guys. Okay, so these are two very, very simple questions. Please do them. हाँ, सब स्मूथ है, सब स्मूथ, कोई फ्रिक्शन नहीं आएगा. फ्रिक्शन के लिए मैं स्पेसिफिकली बताऊंगा कि फ्रिक्शन. हाँ राधिका, सेकेंड वाला सही है, फर्स्ट वाला गलत. हाँ भाई, फर्स्ट वाले का तो आंसर बताओ. फर्स्ट वाले का तो I've just written the answer. नहीं, बात क्या लिख रहा है, सोचना. हाँ राधिका, ये सही आंसर है. क्या हो गया है तुम लोग भाई सुबह सुबह. विवान कहाँ है कि नहीं है? नहीं, विश्वजीत पिट जाएगा, तो मुझसे पिटेगा बहुत तेज. बिल मुझसे. हाँ जोएब सही है. अरे दादा, ये लिखा तो है यहाँ पे. हाँ सोनल, बिल्कुल सही. गुड. जल्दी जल्दी बताओ भाई, सब लोग. मेरे को, मैं जा रहा हूँ. So either you can directly answer this question and say that the velocity at the bottommost point of the circle must be root 5 gr, right? This is the circle, and this is the circle on which the object is going to go round. So if you want the object to go round the circle, then the velocity at the bottommost point must be root 5 gr. But if you don't want to do it like this, you want to don't want to do it like this, so this will be initial रूट 2 GL में हॉरिजॉन्टल क्या लिख रही है, हॉरिजॉन्टल ट्रैवल करेगा, फुल सर्कल नहीं लिखा है। फुल सर्कल लिखा तो है, कंप्लीट इट्स जर्नी ऑन द सर्कुलर पार्ट ऑफ द ट्रैक। So this is the initial point, this is the final point. And then you say that the summation of work done will be work done by Earth plus work done by surface. Work done by Earth will be minus mg into 2r. Work done by surface as usual, 0. Final kinetic energy will be half mv square will be equal to half m into gr, because we know that the velocity at the topmost point for completion of the circle must be root gr. So I get minus mg into 2r is equal to final kinetic energy minus mgr minus initial kinetic energy. So यहाँ से m cancel हो जाएगा, and I'll get v naught square is equal to gr plus 4gr 5gr. V naught is equal to root 5. Or you could directly tell me the answer. Yeah, so please remember the condition that the particle completes a vertical circle is that its velocity at the lowest point must be root 5 gr, or its velocity at the topmost point must be root gr. You can use either of these conditions. So let's see here in the second question. Very, very easy. We want the particle to complete the circle. So either the velocity of the particle here should be root 5 gr, or the velocity of the particle here should be root gr. This is what you have to understand. This is what you have to remember. Now this is given as the initial point, and you can choose and you can choose the final point to be either this or this. That's your choice. I will choose, for simplicity's sake, this as the final point. And I will draw a horizontal line here, a horizontal line here. So what is the work done by Earth? Summation W is equal to work done by Earth plus work done by normal reaction. This is equal to plus mgh plus 0. Initial kinetic energy is 0. Final kinetic energy must be equal to half mv square, but v is equal to root 5 gr, so this should be equal to half m into 5 gr. This is equal to. So I get mgh is equal to half m into 5 gr. M और M कैंसिल हो गया, G और G कैंसिल हो गया, H is equal to 5R, right? Please take a screenshot of this and move on to the next slide. Please take a screenshot. Yeah. By the way, I mean, you should take this seriously because this is how they actually design roller coasters. I hope सब लोग आई मैजिका में गए हैं. तो अगर आई मैजिका में जो रोलर कोस्टर, मेरे को नाम याद नहीं है, जो लूप करता है, नाइट्रो. नाइट्रो, हाँ. तो नाइट्रो में अगर आपके रोलर कोस्टर को 5R/2 हाइट से नहीं रिलीज किया, से कम से रिलीज किया, तो आपका रोलर कोस्टर जाएगा और फिर वापस आ जाएगा. If you want the roller coaster to complete the whole circle, then the height from which the roller coaster is released must be greater than 5R/2. Right? वर्टिकली नहीं गिरेगा राधिका, क्योंकि वो रेल पे रहता है ना, रेल से. अरे नहीं गिरेगा, डब्बा थोड़ी ना होता है वो. डब्बे को स्लाइड पे थोड़ी ना डाल देते हैं, उसमें जो रेल मैकेनिज्म होता है, दैट विल नॉट लेट इट फॉल डाउन. भगवान ना करे आप लोग ऐसी राइड पे जाओ, गिर गया बीच. So the next time you go, right, you can carry out a very simple calculation. You can look at the radius of the ride, the loop, and you can see that जहाँ से वो रिलीज करते हैं रोलर कोस्टर को, that will definitely be greater than 2.5 times the radius. That will definitely be greater than 2.5 times the radius. Or it will definitely be greater than 1.25 times the diameter. So you can either see the diameter or you can see the radius. So what we are discussing here has real world applications. Everything we discuss has real world applications. But sometimes, of course, I forget to tell you about them. So let's design roller coasters. Okay? Let's design some. This is a roller coaster. H. पहले ये वाला करते हैं, इसके बाद से मैं खतरनाक वाला रोलर कोस्टर आपसे डिजाइन करवाता हूँ. So this is H and this is R. Find the value of H if A, normal reaction at the topmost point is, oh very nice, देखो मैं कैसे लिख रहा हूँ, is twice the weight of block. normal reaction at point P 5 times the rate of thought. Okay, now this is, there is no completes the circle here. So no root 5gr and no root gr. The initial point is given to you. Right? And if you look at part A and part B, the final point is also given to you, right? Part A में बोलते हैं n at the topmost point of the circle. Of the circle है ये, topmost point of the circle. हाँ, starts from this. Of the circle. So इसका mass m है. Starts from this. So the initial point is given to you, and for the individual parts of the question, the final point is given to you. Right? So choose the initial and final points and write down the work energy theorem first, assuming whatever is unknown. And then look at the part of the question once more and try to figure out another equation which will help you solve the question. नहीं राधिका, इसकी यूनिट्स गड़बड़ है ना. You can't have an answer mr/2. No, it cannot be r/2. You can't. r/2 का मतलब तो ये हुआ ना कि यहाँ से आप रिलीज कर रहे हो. r/2 का मतलब क्या हुआ? यहाँ से रिलीज किया ना. यहाँ से रिलीज करेंगे तो ऊपर कैसे जाएगा? ये कैसा रोलर कोस्टर है? cos थीटा कहाँ से आ गया भैया? हाँ राधिका, सही आंसर। हाँ जोएब, सही आंसर। चल देखो भाई, जो लोग नहीं कर पा रहे हैं, विवान कहाँ पे है भाई? यस नो तो एक बार टाइप कर दे। नहीं हुआ ये क्वेश्चन विवान? Initial point given, normal reaction at the topmost point of the circle. The final point should be at the topmost point of the circle. Right? Now I'm going to apply the work energy theorem. Before I do anything, I'm going to apply work energy theorem. So this is the horizontal line here, this is the horizontal line here. Now this distance is h, this distance is 2r, so this distance must be h minus 2r. Okay? So work done is work done by earth plus work done by normal reaction is equal to plus mgh minus 2r plus 0. Right? Remember, the key is to find the vertical distance between the initial and final points, which is simple. Not even geometry. This is simple measurement. So initial kinetic energy is equal to 0. Final kinetic energy is equal to half mv square. So I get mg into h minus 2r is equal to half mv square, and that's it. End of story. I cannot do anything with the work energy theorem anymore, right? And the work energy theorem expression contains two unknowns. One is the height h and the other is the velocity v. So I need to find either, well, either की बात ही नहीं है, I need to find v so that I can find the value of h. To find v, what I need to do is that I need to go back to the question once again. And when I do, I read that the weight of the normal reaction at the topmost point is twice the weight of the block. Okay. So I know that at the topmost point, this guy is executing circular motion. Okay. Because normal reaction is not zero here, it is twice the weight of the block. That means definitely it must be executing circular motion. इसकी velocity v है यहाँ पे. So I draw the tangential axis and I draw the radial axis, and then I draw the forces acting on it. Mg is acting on it and N is acting on it, right? So for the second part, because it is in circular motion, I am going to write summation of radial forces is equal to mass into radial acceleration. So in this case, I will get mg plus n is equal to mv square by r. Right? But it is given that n is equal to 2mg. N at the topmost point is twice the weight of the block. So I get 3mg is equal to mv square by r. This means that v square is equal to 3rg. Right? And I come back to this equation now. Now I can write mg h minus 2r is equal to half m. Now I know the value of v square now. I worked it out from the concept of circular motion into 3rg. Right? So mg and m 3RG, mg and mg cancel out, and I get h minus 2r is equal to 3r by 2. This means h is equal to 3r by 2 plus 2r, which is equal to 7r by 2. हाँ, ये आंसर सबका गलत, मार्क का सही और मेरे को नहीं सबका तो सही था ना, 3.5 आ रही तो बोला था 3.5. Okay, now please do the second part in exactly the same way. सेम आंसर आ रहा है क्या ऋषि? I'm going to change the slide. Same answer आ रहा है? Okay. Okay. Initial point, final point. Third part भी है उसका. For those of you who've done the first and the second part, there is a third part as well. Third part is here. This is angle theta, point Q. N at point Q is 3 times the weight of the block. Right now, I have written weight of the block. I have written normal reaction is something weight of the block. In the question, the words may be different. Okay, some of you might get questions where the words may be different. The block pushes the circular track with a force equal to 3 mg. Right? That would have the same meaning as N at point Q is 3 times the weight of the block. The block pushes the track. The block applies a force on the track which is equal to 3 times the weight of the track, weight of the block. Again, the same meaning. N at point Q is 3 times the weight of the block. Right? This angle theta is given now. This angle is theta. So in terms of theta, now you're okay. So this angle is theta. हाँ, ये वाला क्वेश्चन मैं कर रहा हूँ. So the initial point is this. Final point is this. I know that this whole distance is h. This distance is r. So this distance must be h minus r. Summation of summation of work is equal to work done by earth plus work done by surface. This would be equal to plus mg h minus r plus 0. Initial kinetic energy is 0. Final kinetic energy is 3 times. Final kinetic energy is half mv square. So I get mg into h minus r is equal to half mg square. Screenshot ले लो बच्चा. Keep taking screenshots, please. Remember, मेरा connection कभी भी सब कुछ उड़ा सकता है. So now we know that the object here is in circular motion. Definitely, forces acting on it must be mg and normal reaction m. So we get n is equal to mv square by r is equal to 5 mg. This is given, right? I'm getting this from the concept of circular motion. So v square is equal to 5gr. mg h minus r is equal to half m 5gr. mg cancels out. H is equal to r plus 5r by 2, 7r by 2, 3.5. Exactly the same answer. So now follow the same method, same principle. Please take a screenshot here. Please follow the same method, same principle to do the third part. Please take a screenshot. I think this is the correct answer. हाँ हाँ ये आ रहे हैं ना कॉम्प्लिकेटेड वाले पे, ये आ रहे हैं, we are coming on that. So for the third part, the final point is here. So this is angle theta. हाँ तुम करो ना, मैं केवल आई एम जस्ट डूइंग द प्रिलिमिनरी वर्क. So this is height h, I know this. This is r, and this is r sine theta. हाँ Alright, method wrong. So work energy theorem, work done by normal reaction plus work done by 0 plus mg into h minus r1 plus sin theta. Initial kinetic energy 0, final kinetic energy half mv square. Mg h minus r1 plus sin theta is equal to half mv square. So this is the work energy theorem, and that's it. Work energy theorem का काम खत्म हो गया. Next, again we realize that this is the tangential axis and this is the radial axis, and the forces, सही है. And the forces acting here are mg and n, like this, right? So the component of mg along this line will be equal to mg sin theta. So from circular motion, I will get n plus mg sin theta is equal to mv square by r. n की वैल्यू मुझे दी हुई है. So this will be m3mg plus mg sin theta is equal to mv square by r. Right now, substituting the value of v, I will get mg h minus r1 plus sin theta is equal to half mv square, और v square की वैल्यू है rg 3rg plus 3rg, sorry, half m 3rg plus rg sin theta. m और g कैंसिल हो गया, तो मेरे पास आएगा h is equal to 3r plus r sin theta plus r sin theta. राइट, ये लेफ्ट हैंड साइड से राइट हैंड साइड में लेके आया. h is equal to 4r plus 2r sin. नहीं, मैंने कुछ गलत कर दिया ना? नहीं, सही तो किया है. नहीं, गलत कर दिया. नहीं, गलत कर दिया. क्या हुआ भाई, सब लोग सो रहे हो क्या? हाँ, तो गलत है तो बताना चाहिए पहले ना. पूरा लिख रहा हूँ मैं. I forgot the factor of 2. So 2h is equal to 3r plus r sin theta plus 2r plus 2r sin theta. So h is equal to 5r plus 3r sin theta whole divided by. राइट, अभी सही है ना? यही आया था ना आंसर सबका? हाँ, उत्कर्ष का भी ये आया था. पार्थ पता नहीं क्या लिखा है. हाँ, सबका यही है. चलो, अब आते हैं भयानक वाले. Please take a screenshot. Now we come to the भयानक वाला roller coaster. So we have a roller coaster, and we will release the We'll release the people, the ride from a height edge, right? Now, the thing that is special about this track is that this portion of the track, is removed. Okay. इसका मतलब जो track है, that is like this. And this angle is 2 theta. Let me call this point A, let me call this point B. So, part of track between point A and B has been removed. Find H so that block will leave, or let me just write it, block will complete the journey on the track. Right, so this is a very, very dangerous roller coaster. And what is going to happen here is that as the block comes down, anybody willing to tell me what is going to happen? Anybody willing to take a guess what is going to happen? क्रैश तो सस्पेक्ट तो फिर मैं क्वेश्चन ही नहीं पूछता ना. यस अभिजीत, वेरी गुड. यस, वेरी गुड. So this is what is going to happen. As this guy comes down, go like this, dub up the track like so, and then after this point, so up till this point, there is circular motion. Very good. Yes. After this point, the object will go into projectile motion, such that it must land exactly at, which I am unable to draw, it must land exactly at point B. Projectile. Very good. हाँ, राधिका एक टर्म आप मिस कर रही हैं, but yes, you are right. चलो, now try this. So instead of giving you the normal reaction at point A, I am trying to tell you the velocity at point A in a different manner. That's it. That's the difference between the previous question and this question. Radius R is given. Mass M, radius R, everything is given. बताओ, you tell me. Think. I don't think there are many possibilities. नहीं नहीं नहीं. हाँ. If you are confused, please remember that A is the final point. हाँ भैया बिल्कुल सही है. नहीं नहीं, कुछ कुछ गड़बड़ है उसमें. हाँ. Okay, so like I said, it's just about giving you the final velocity. The problem is complicated, or the problem seems to be complicated, because small r, capital R कहाँ से आया? So first, let me choose the initial point and the final point. Now you may ask, why is A being chosen as the final point? Well, the thing is that at point A, I know that the particle will start executing projectile motion. Therefore, maybe I can figure out the velocity of projection. Right? How can I do that? Well, there is a condition. The condition is that the particle should leave A and should land exactly at B, right? Otherwise, then, like Smith said, the crash ho jayega phir. We want this roller coaster to leave the tracks at A and rejoin the tracks at B, so that it can continue its journey on the tracks, right? So maybe at point A, I will be able to figure out what is the velocity. And the work energy theorem that I'm going to get, you there will be two unknowns in that. One will be h, which I have to find out, and the other will be velocity. So if I can figure out the velocity, maybe then I can figure out h. So between these initial and final points, let me first figure out what is the height. Well, I know that this distance is r, okay, and if this is 2 theta, then this must be theta, and therefore this distance must be r cosine theta. Right, so this distance must be h minus r1 plus cosine theta. So from the work energy theorem, I get work done by Earth plus work done by normal reaction. Work done by Earth will be equal to plus mgh minus r1 plus cosine theta. Okay, and work done by normal reaction is zero. And we know that initial kinetic energy is zero, and the final kinetic energy will be something half mv square. So again, I'll get the same kind of an equation which we have been getting for the past 5 questions now, and this will be that mgh minus something is equal to half mv square. यहाँ तक सब कुछ same. अब जो difference आ रहा है, that difference is in the fact that here the v is the velocity, the initial velocity for projectile motion, right? And if this is angle theta, then this must be angle 90 minus theta, and this must be angle theta. So the projectile has been projected with a velocity v at an angle theta, and we want this distance to be the range of the projectile. तभी वो B point पे land करेगा. So the range of projectile must be equal to 2r sine theta, right? From this right angle triangle, we see that the hypotenuse is r, this angle is theta, so this distance must be r sine theta. So total range is 2r sine theta. And I also know that for a projectile which is projected with velocity v at an angle theta, the range is given by v square sine 2 theta by g. Right? So this will be equal to 2r sine theta, and therefore I'll get v square is equal to, okay, 2 तो cancel हो जाएगा because the sine 2 theta can be written as 2 sine theta cos theta. V square can be written as rg upon cos theta. So I will get here then mgh minus r1 plus cosine theta is equal to half m rg upon cos theta. Mg and mg as usual they cancel out. H will be equal to r1 plus cos theta 1 plus cos theta plus 1 by 2. Right? Okay. Take a screenshot, please, and go to the next question. Okay, so now I want to, before we go, just want to discuss what happens when V is greater than GR less than root 5GR. कौन सा पार्ट नहीं समझ में आकाश? कौन सा वाला पार्ट नहीं समझ में आया? ये वाला या ये वाला? तो वही तो मैं पूछ रहा हूँ ना आपको, रेंज ये वाला नहीं समझ में आया कि ये वाला नहीं समझ में आया? कौन सा नहीं समझ में आया? बताओ भाई, you have to tell me ना, then I'll explain ना. ये वाला, do you agree that here we have a right angle triangle? Do you agree that we have a right angle triangle here? What is the hypotenuse of this right angle triangle, Akash? What is the hypotenuse of this right angle triangle? Good. And what is the angle of this right angle triangle here? ये वाला angle जो है ये क्या है? ये वाला angle कितना है? ये total angle 2 theta given है ना? ये वाला angle कितना होगा? Okay. So if in this right angle triangle you know the hypotenuse and you know that this angle is theta, and what is the length of this side? What is the length of this side? ये साइड की लेंथ क्या है? यहाँ से लेके यहाँ तक का लेंथ क्या होगा? यहाँ से लेके यहाँ तक का लेंथ क्या होगा? I should have written actually vertically symmetric. I'm sorry, but I'm telling you that this is vertically symmetric. यहाँ से लेके यहाँ तक का लेंथ क्या होगा? नहीं बेटा, r sin थीटा तो यहीं से यहाँ तक का है ना. I'm now asking यहाँ से यहाँ तक का लेंथ क्या होगा? AB लेंथ क्या होगा? मेरे आपके घर के बीच का आकाश हाफ द डिस्टेंस 5 किलोमीटर. टोटल डिस्टेंस कितना हुआ मेरे आपके घर के बीच में? हाँ, गुड. So that is how I got this. अभी आया समझ में? और ये तो रेंज का फॉर्मूला ही है, ये तो हमने प्रोजेक्टाइल मोशन में पढ़ा था. ओके, गुड. So now I want to show you what will happen if I launch this guy with a velocity of root 4g. A bomb of mass m is suspended by a string of length L, which is fixed at point O. It is now given a velocity of root 4gl as shown. Find A point where projectile motion starts. B velocity at that. So somewhere here at an angle of theta, projectile motion starts. Right, so I want you to do this question. We will discuss this question in the next class. And I have shown you the initial and final points, right? The initial point is here, final point is here. And I told you in the last class what happens here. I told you in the last class that the tension at this point will become zero. Okay, tension at this point will become zero. So what you need to do is you need to apply the work energy theorem between these 2 points. And then at the final point, the tension has become zero, but you can still consider it circular motion, right? Because of the boundary condition. Remember, हमने friction में पढ़ा था, the block moves and the block just does not move, दोनों equivalent. So in the same way, the fact that circular motion is ending at the final point and projectile motion is starting at the final point, you can consider the motion at the final point either circular motion or projectile motion or both for mathematical purposes. It does not matter. So you are going to consider the motion at the final point as circular motion and assume that tension is zero. Right? And then again, अभी तक हम जो करते हुए आए हैं, again you will apply. So you will get another relation between V square and this theta, right? That should help you to find part A and part B. Okay? Please take a screenshot of this. Stop now, and I will see you in the next class. Okay?